Imagine you're at a water park. Now imagine that you're sitting in a wave pool. There are hundreds of people waiting in anticipation of the wave to come. You wonder, what is the maximum height of this wave? To find the height of this wave, we need to use derivatives and do some simple calculations. This can be used to find the maximum of a sound wave, a light wave, or even a mountain range. Today we will apply the way to find maximum and minimums of equations to the heights of waves in a wave pool. To find the maximum or minimum of an equation, we start with the equation f of x. Then we take the derivative f prime of x. So let's say our equation is f of x equals x cubed. So the derivative would be f prime of x equals 3x squared. Then we set f prime of x equal to 0. When we solve, we get x equals 0. Then we plug x equals 0 into the original equation and get the point 0, 0. Then we use a sign chart. We place the point 0 on a line and pick a value higher and lower than it, in this case, 1 and -1. When we find the y values at those points, you get negative and positive values, which is the graph moving from negative to positive, which makes the point 0, 0 a minimum. So now let's apply this to our wave pool. You are sitting in the wave pool and a wave is rushing towards you. The equation of the line is sine of x. We need to first take the derivative. The derivative of sine of x is cosine of x. Now we solve for 0 equals cosine of x. We get x equals pi over 2, 3 pi over 2, 5 pi over 2, and so on. When we plug it into the original equations, we get y equals 1, -1, 1, -1, and so on. Now we apply it to the sign chart, and we get the graph moving from positive to negative to positive to negative, which makes pi over 2 and 5 pi over 2 our maximum x values. We plug them in and find the maximum height is 1 meter.